Yeah, I'm Abby. I'm living in Grandview, and my major's a little weird if you're thinking about environmental sense. I was a biomedical engineer at a cabinetry industrial plant, but I do have a background in electrical systems um, to be in biomedical engineering. So that was what a lot of my main focus was, at least my internship. So this is basically a summary of the projects I've done. Um, I realized I probably need to revise some based on how everyone's been presenting it. I didn't realize that a lot of these projects are actually connected with each other or affecting one or the other. And it's really interesting to see how those are differently presented throughout the day. So a little bit of a company overview. So Grandview Cabinetry manufactures wooden kitchen and bathroom cabinetry in different various stains and paints. And originally it was in Grandview, Missouri, and it moved to Parsons in about 1965. And then in 2018, Woodlawn Cabinetry decided acquired a company, and ever since then they've been Grandview Cabinetry. So the difference between the two is that uh, Grandview works with multifamily homes in which they make units of cabinetries for buildings such as apartments and usually hotels, ones with multiple units, whereas Woodmont, their parent company, works with a lot of single family homes. So right now it has 133 employees with about 25 in the north plant. I'll get into the difference between the north and the south and the main plant. But they also used to have a third plant in Cherryvale, which shut down. Actually, they said it's about a year now since they shut it down. And in 2022, when P2 brought an intern in, they earned the EPA Pollution Prevention Award. So, to start off, I did an electrical analysis because I was approached with a few projects that involve with electric forklifts, improvement to airflow, and finding alternative packaging materials, and also just there was the whole new OSHA rule for heat related illnesses at a workplace. So they were really curious about what are some things affecting that, and is that affected or shown at least in an electrical sense. So I did an electrical analysis. I was saying, at least in 2023, they used up about 143,000 kilowatts of energy, and the main plant now is projected to be about the same. It's in they're pretty similar in prices, and this was the value I used for a lot of the analysis for the future solutions that I wanted to provide. So a little bit about forklifts. Right now they have three models, so Proud, Toyota, Mitsubishi, and then they're all bought secondhand, which makes calculations a little hard because we're accounting for a lot of the use beforehand and also the use during that time. But as of now, they have three forklifts at the main plant and two at the north plant. So some things about electric and propane forklifts. I know there's a lot of numbers there, but I'll go around and explain some of them. With electric forklifts, the way they work is they're charged, and all the electrical energy is converted into mechanical energy, which is used to power the electric forklift. So when we were figuring out the cost, I was trying to figure out how much energy does each known processes that the forklift does equate in, at least in electrical terms. So I figured out, okay, I got a couple quotes, and from those, I figured out if I were going to be operating it at the current schedule that they're at right now, how much energy would that be? how would I calculate that, and how does that equate to propane? So how would I turn propane into electrical energy? And so I figured out the operating cost per hour and then the total. And then after that, I also calculated all the kilowatts here and what they equate to energy wise. So what we found out is that from an environmental standpoint, the emissions are negative. And the reason for that is that the electric forklifts themselves don't emit any emissions, but it's the power generation that the power company is bringing to the plant that's emitting all those emissions. And that's why the value is negative. So, in the perspective of usage in a company, it has its advantages, as in you're using less propane gas, and the maintenance is also less too. There's less tune-ups, and the fact that a lot of the electric models are very smart in their systems on using that electrical energy is more of a positive. However, for the case of Grandview, I decided to suggest to them that they should probably stick with propane, since they are a smaller company, and just using that propane forklift would probably get the job that they need done at a lower cost. And if they were to invest in electric, then that would make the payback period quite long, even if it's used. So the next project is improving airflow. So what I did was I went around and collected all the different types of fans there were in there, because that is the current system of the plant. So I figured out there were two big fans, and there were about 9 of those Patterson leaf fans. And the reason that they're oriented this way is I'll explain a little bit later, but it's a lot of what maintenance has been trying to do with the airflow. So everything in yellow are basically garage doors. And a common thing that I got from maintenance is them complaining about how everyone just keeps opening their garage doors. And you might ask why. And they think it's because it's to let in more air. However, as they're trying to make the airflow better inside the building, you want to make sure that all that air that you're making inside stays inside, instead of also inputting out in from the air from the outside. And I believe I just got this quote yesterday, but from one of the maintenance people, the plant is producing 110,000. It's taking in 110,000 CFM, so cubic feet per minute, and the plant is only producing only 71,000 CFM inside the building. So they're technically taking in more air outside than inside right now, that they're making inside right now. So that leads me to, how does that affect the temperature? So I did an ambient temperature study where I took different areas of the plant, everything in the red X, and tried to see if there was anything specific that the temperature affects the workers, or if there's been airflow or something of that sort, just to see what is the current situation. So I took this at 8 a.m. bright and early in the morning, and then I took a set, and then I ended it when production was gone at the end of the day. And I just noticed that a lot of the trends are just slowly going up following the temperature outside. One special thing I want to point out about this slide is the Sanders. So the reason I took a bigger sample size is because talking to the people at Sanders, they said the temperature affects a lot of how their work is done, because wood in general is affected by the temperature in which they would expand, or the air around it affects the way that they're sanding it down. So their machine just kept breaking down, and they always thought it was just the temperature not being constant. However, when I was looking at it, I was like, it's similar to all of the rest of the places at the plant. So it's not really temperature that's making it mess up. So what is it? Um, Another thing that they mentioned is that at the north plants, Cherryvale closed, a lot of the machineries there are using up a lot more energy and electricity than the ones at main plant because they're a milling plant. They work a lot with cutting down wood into cabinet doors and frames. And so I decided, you know what, for fun, we'll see how that affects in a whole day period, since we already know that they're using a lot of energy there. So based on this, I took the temperature at the same time in the morning, and then at the peak is usually the time that they end their shift. And then you can see that there's quite a steep curve that goes down on that chart because they turned off all their machines. They're very good with that. They open up the machines whenever they're in use, they close them when it's not in use. So we figured out that maybe the reason it's really hot in that plant is because it's something mechanical or machinery wise, that's where all of the temperature is coming from. So one of the things I looked at first was compressed air. So in terms of compressed air, I found about 110, 112 leaks in the plant. A lot of it were at connection parts where they had the couplers, the quick release couplers, and then a couple of hoses. So based on the leaks I found, I took the price of the couplers that they would need to buy, and then it would save them $22,000 for the main plant to fix all the leaks, and then at the north plant, over $6,000 with a really fast payback. So another thing I looked at when I was investigating, so what is happening with air, is a duct collection system. So in the cabinetry facility, there's the every single machine is connected to a dust collection system, and every time that they're using sawdust or working the machine, it takes up all of that sawdust into that central localized system and baghouse system. And that baghouse system uses a lot of energy. So what I was trying to figure out is there a way that I can make either the big dust collection system more efficient or the smaller ones? So what I found out instead is there's a similar system in the North plant that they've already started to implement. This bottom right picture was just taken Tuesday because they decided to add a variable frequency drive. So their main dust collection system spans through the center part of their facility, and spreading from that center ones are a bunch of smaller ducts that are connected to machinery, and it's also integrated to their exhaust and ventilation system. So all of the heat that is produced by this machinery is brought up into that center pipe and head outside. However, one thing that they did notice is that they implemented a ductwork design where the overall duct goes back into the facility to make sure that the facility is still there's enough air circulating through the facility. However, that does raise the temperature within the plant. So as of right now, I believe they're making a plan to create an exhaust system where they can toggle when they want the plant to have more air inside and when they want it to be outside. And one of those toggleable things that they have put in are the blast gates. And right now they are using manual ones because they don't need a lot of machinery to be, there's not a lot of machinery that is turned off and would need that to be shut. But as of now, that is the place where they found that a system like a variable frequency drive, which I'll get to here in a second, is more efficient at the north plant versus the main plant. And I was originally looking at the main plant. So what is a variable frequency drive? I had to learn how the electrical power is turned into mechanical power. And the way this works is that there are magnetic poles inside a motor, and from those poles, the electricity is converted. The input of electricity is converted into mechanical energy by spinning those poles. So by adding a variable frequency drive, the machine is able to control the steep transition between electrical and mechanical energy. So when they add this to their system, there is a certain amount of efficiency it can have depending on the efficiency rated on their motor. I just got these all 2 or 3 days ago since they decided to install it immediately before I even finished the presentation. So this was the one installed. Horsepower that they're having at the plant. So to implement it at the main plant, it would be to do another motor analysis at the main plant to determine if this is efficient for the north plant and if it will be efficient to the main plant. So I decided to do something easier, and that was fan usage. I then decided to see if there's something we could do with the amount of fans that are in this area. And I just decided to monitor the habits of the workers and who actually turns off the fans and who turns it on. And that was on a 5-day period. And from that, I gave them a suggestion of 2 locations for fans that they could place based on payback period, based on the the temperature study that I did, and also based on what type of fan would be the most efficiently using the electricity. And again, there was also the talk about solid waste being used in the plant. There was a great decrease in it from 2021 to 2024. But the question is, where is there still waste coming? And what we found is that it was from the packaging of all these materials. In the process of wrapping these from facility to facility, they are rewrapped 3 times, hand wrapped 3 times, and they're just moving it from one area to the other. And in addition, there's a lot of rejected bad doors that they end up throwing away immediately and is sent to the garbage. So I decided to look at multiple options to reduce the amount of packaging waste that it was creating, and I figured out each year that they were making about 2 tons of waste just from plastic alone, space in the process. So the company I contacted was AIM Reusable Packaging. However, it was a lot of back and forth since a lot of theirs was customized, and they never gave me a average weight of per pallet since they were like, it varies order and this and that. So I had to find multiple ways on how to find it. So what I did was I looked around the entire process and figured out 455 doors typically stacked on it, and the size on it. This was all just based on observation, and we decided to do a quote with that company. So again, moving with the defects rate, I marked 3 areas where they saw an increase in defects rate, which also increased their waste from those cabinets that they were throwing away. So it turns out those were from Woodmont orders, since they're from singular family homes and they have a higher standard of quality. So this is more of an in progress type of project, because I found this out as I was learning through finding the answers for the other projects, it just ended up being more of a bigger issue than it was. So at the bottom of it, it seems like the process itself needs an improvement. So what I did was I mapped out the material flow of the place and identified some bottleneck areas that I saw were accumulating a lot of waste. And as of right now, we're working on a measurement plan to figure out how to quantify those areas that is a bottleneck. A lot of them are in the central area where a lot of it is stored halfway through the process. And that is because those cannot be moved until everything else is finished of the cabinet to be assembled later. And that was all found to be true also with the temperature audits because it's also really hot in those areas too. And so it's very interesting that the conclusion we ended up with, and it was a little difficult to have to quantify it all into numbers for sure. But yeah, just a summary of my projects. I would say the greatest environmental result would be from the air leaks. Otherwise, if they're looking to change the different fan systems, they would also get some environmental results. But switching to electric forklifts, I wouldn't recommend it for that specific reason. That should be it. Any questions?
The audience?
Yes.
Could you go back just a few slides to the defect rate, defect percentage?
Yeah.
So there's something interesting that I'm wondering, why are the defects higher in some months? Maybe there's a correlation between number built and the percentage of defects. Do you know why are there
is there a
higher?
specific area that months that you're looking at?
Yeah, so like take July. It looks like there's a lot of door tags and door builds compared to some of the other months, and there's a really high defect rate. But in October, there's about the same door tags and more door builds, but the defect rate's a lot lower.
A lot of it is just based on the order, and it was hard for me to figure out how to get a steady number throughout all that because they were like it's customized for every customer and the amount of units needed in the project that they need. But what was steady about this is the consistent defect rate whenever they were just producing Grandview cabinets. It started going up when a lot of the Woodmont cabinetry got put into their system and their need for quality is at a higher rate. So they would reject more. So that was interesting to figure out. At first I thought it was like, oh, they're just making more waste. But in reality, it was just the process that is creating more waste and also the integration of new systems into it. Any questions? Yes.
Sorry, when there's a defective door, is defect just based on their quality control, there's certain standard they give to the customers, or defect like it is not capable? And if the answer is that it functions, it's just not within the standard of quality control, is there any way they might be able to, resell those at some sort of discount?
As of right now, they only have one person running quality control at the end of paint line. So the workers that are throwing away these doors find physical defects that will affect it in the spray paint, the paint line. So usually the quality control is there to figure out, is this coming out the way we wanted it? And the workers are trained before it, or they're supposed to be trained before it to take out the ones that they realize aren't going to be painted well. And that's kind of where they're getting the defects, and thus they have to call the whole system again to make new ones, and then they would have to create it, and then a lot of that waste is actually coming from just the process itself. Yes.
So you mentioned there's only one person doing quality control. Is that the person that is deciding if the door is pass or fail? Or what's
There's only one person doing quality control on if the paint finish is good enough.
okay, so after.
Yeah,
Okay.
and then that's the only person that they're working specifically for quality.
Mhm.
The one who tracks rate is actually at the paint line right now to see if there's anything else affecting the defect rate at this moment, or if there's a standardization that they can implement with the findings of this. I looked into the standards, but again, it was more of at first it was they thought it was the ambient temperature, how it's not always constant, but there's still some process investigation that can definitely be done to quantify a lot of these things.
Do you think if you have people controlling in, for example, in earlier stages, can you maybe redo a little bit of work and make the door or piece of furniture up to quality for painting afterwards? Do you feel like, because I can see, for example, when it's all the way at the end of the line, you may have to throw that away because there's just, it's too late. But do you think that if this is caught at earlier stages, they can maybe just fix it?
So all the workers are trained to figure out when a cabinet door is supposed to be approved or not. And recently, there's just been not a lot of participation in that type of behavior. So it's more of they need to change the culture within the company to be able to implement kind of that system. So I was looking at different ways to figure out if there's like something to incentivize them, or if there's a way in a different part of the process that it's affecting their kind of motivation to do it. Yes.
So you mentioned temperature tracking, and yes, humidity is definitely something, right?
I did not input. I did have the humidity plotter. However, I just was having a hard time figuring out how to work it in general. Because the way that they're connected was I was trying to figure out a way to show them ambient temperature, but then also humidity would also bring another factor, which I was like, we'll start with one thing at a time since just the ambient temperature takes a really long time to do. It would be like, right?
Temperature does affect you, but if your day is dry, your wood's not going to as much, you might not have as much leaves. So you're going to have emphasis about I don't know. There's certain routine. Your wood fiber is going to have different texture.
Yes.
I think the defects look to be a lot higher in the summer. Maybe I don't know if you have a way to quantify this, but when you're sending your findings for that improved air, have these factored in perhaps some sort of benefit and reduction in defects from improving the airflow guard. It seems like the hotter months you're getting more failures in the system. Maybe that airflow would correct that.
Yeah, that's why we were looking a lot into the airflow and if temperature is actually the entire process, and why I went into a lot of detail on like why are these why is there not a lot of participation? Is it more of the employees not being happy in their environment? Is it more of the process? Is it more of like trying to figure out the little minute differences that does make a big impact on the entire system?